Hello everyone! So today we don't have much visual features to discuss on the tree designer itself, so instead we'll be focusing on the GUI updates. The first thing I introduce is the support for widget tooltips, and you can see that in action just here if you don't move the mouse for more than 0.5 seconds on a given element. So if you just move here and stop, you see the pop-up, which is a tooltip for this line. It's also working here for checkboxes and combo boxes, even for buttons here. And with the current implementation, as soon as you start moving the mouse again, the pop-up will disappear. Defining a tooltip for a widget is as simple as this. You specify the text that you want to display for the tooltip. And when it's time to display a new tooltip element, we will call this method, and this will by default create a new text tooltip widget, which will be used to display a simple text. But the cool thing is that eventually I could use this to display more complex tooltips widgets, so with buttons or additional content for instance, and the system for this is already ready. There is not much to say concerning this text tooltip class, apart that you already have control with those threads on a lot of different settings that you could customize when you are actually creating a new instance of the class. And on the implementation side, this text tooltip only use 3 different elements. The first one here is the background element, so this is a simple rectangular shape. Then we have on top of that the border element, which is well, the border element itself is here, so that's a dedicated shape, and we have also the backdrop, so 4 elements in the end. And also next we have this text element to display the actual text, so that's where you would actually set the value that you want to render. Next point I would like to discuss is the support for basic shapes in the rendering system. Actually, I had already explained in a previous video how the system I have currently works for the rendering on the GUI, and this is mainly based on using paths to do the rendering. So you take some path and generate polygon from that, and then you have a pretty complex system to actually rasterize those polygons manually, building what I call a coverage map, giving you the alpha value that you want for each pixel. But yeah, we're not going to go into additional details concerning this point in this recording, because that would probably take hours to cover this properly. So let's focus immediately on the basic shape concept. So the main idea is that when you need to render a very complex shape, like this one for instance, with maybe some holes in the middle, then you can definitely go and use the Path 2D rendering system that we have available by default, and that would be the best solution. The problem is when you use this kind of path rendering system, you also need to render a very large coverage buffer. So for this path you will need to cover a given area with a value indicating what is the coverage for every single pixel one by one, and this data needs to be made available somewhere to your rendering process afterwards, so this is taking some space. So I have a very large coverage buffer where we put all this data, and it's growing progressively when you're adding bigger and bigger paths. But the point is, even if you just need to render a rectangular area like this one for instance, using this path rendering system, you will still need to be preparing this coverage buffer for this area, so you will be filling all those pixels here with full coverage, so an alpha value of 1. And that actually feels a bit useless, because if you know that you're rendering a rectangular shape, then you don't really need this information here. You can really figure this out when you are rendering the actual shape. And the thing is, when you start rendering GUIs, you actually pretty quickly realize that you most of the time need only 3 different shapes. So basically you can be rendering rectangles, or you could be rendering rounded rectangles, so that rectangles with rounded borders, even if the borders here could have different radius for each corner. or you could be rendering a spherical object. And if it's a spherical object, you can even consider that as a rounded rectangle, where the radius here is half of the width and the height of the rectangle. So actually you would be rendering a square, and you would be using the same radius for all the corners. And so it means that to render a sphere, you can actually render a rounded rectangle, and to render a rectangle, you can also render a rounded rectangle with a radius of 0. And in fact, it turns out that rendering rounded rectangles is pretty easy when you use SDF, so that signed distance field. So you can have a very simple function here that you can use to figure out if any given point is inside or outside of your rectangle. So if you want more information on that, you should search for Inigo Quilez. That will point you to this website, and you will find a lot of definition for SDF. So I then updated my render shader to have this additional option to support those basic shape. And then I will use this getBasicShape coverage function as a dispatch function to access the other additional shape-specific coverage computation functions. And currently I only really have two options, so either we're not rendering anything or we're rendering a rendered rec. And here is the implementation I have, for instance, for the rendered rec coverage, which is using this SDF rendered rec function internally, and also it's actually performing additional step here because I support also rendering the shape with a given stroke width. And just for reference, here is the SDF computation function, which is directly taken from the Inigo Quilez implementation. And the very cool thing now is that since we have generic parameters specified when building the basic shape, it would be fairly easy to specify the settings we need to render all those additional SDF. And finally, the last thing I would like to mention is the implementation of the ScrollArea Widget. So this took me actually a lot of time and effort to get it done correctly, because there were always a lot of small bugs and small corrections to add, but now it seems to be working just fine. So as you can see, now we have the scroll bar, and in fact all the content we have for this tab here is part of a scroll area, and if you grow the tab, then at some point you don't need the scroll bar anymore, so it will disappear, and it will also update the layout of the content, so it's taking a little bit more space here, as you can see when it's moving like that. The idea here is that now the content that you have here is going to be clipped, so we apply a scissor area to ensure that no content will be leaking behind or above the actual area of the scroll. So you can also, of course, use the scroll bar directly, and you can move that up and down. If I change the tab, actually we have different scroll areas for every single tab here. So here in this case you don't actually need one because the smaller size that you can get is still too big, but then there's this one also, but here you can have one, and I can even use the mouse wheel to actually move on the tab. So this is pretty cool, and it's going to be handy to reduce the space taken by the different widgets that we will be building in the future. Alright guys, so this is it for this time again. I hope you enjoyed this recording. If you have any question, as usual, just let me know in the comments, and otherwise I'll see you next time when I have a new update for this project. See you and have a nice day. Bye bye.